today we are going to discuss cement. Cement is the most commonly used binding material in construction. It is obtained by burning a mixture of calcareous material, that is material which contain mostly lime or calcium, and argillaceous material, that is clay. So both these materials are mixed together and then burned at high temperature. So while burning, clinkers will be formed. These clinkers are ground to form a fine powder. So this was first introduced by Mason Joseph Espedin in England in 1924, and he named it as Portland cement. So the cement is a key ingredient of concrete, mortar and cement paste. So concrete is made by mixing cement, water and coarse aggregate and fine aggregate in proportion, which is mainly used for making all the structural elements like column, beam, slab, etc. Next is mortar, which is made by mixing cement, water and fine aggregate in correct proportion, which is used for all the plastering work. Then cement when mixed with water will form a paste, which is used mainly for all the finishing work. So next we will see the raw materials required for making the cement. So the main raw material is calcareous and argillaceous material. Calcareous material are material which contain calcium or lime. For example, limestone, chalk. And argillaceous material, that is material which contain alumina as the main constituent. Example, shale, laterite, etc. So this material provide silica, clay, oxide of iron to the cement. So here you can see the calcareous material, that is the limestone, and the argillaceous material, that is clay. So next we will see the composition of ordinary Portland cement. So first one is lime, that is calcium oxide. So the percentage of calcium oxide available is 62 to 67%, and the main function of the calcium oxide, so it provides strength to the concrete, and the excess lime make the cement unsound and cause the cement to expand and disintegrate. If the lime content is deficient, then the strength of the cement is decreased and causes the cement to set quickly. Second ingredient is silica, that is SiO2. So the percentage of silica available is 17 to 25%. So now the function is, it imparts strength to the cement due to the formation of dicalcium and tricalcium silicate. So the excess of silica increases the strength, but the setting time will be prolonged. So next ingredient is alumina, that is Al2O3. The percentage available is 3 to 8%. So now the function of alumina, it imparts quick setting property to the cement, and it acts as a flux and lower the clinkering property, and the excess quantity weaken the cement. So next we will see the other components available in cement, that is calcium sulfate, that is CaSO4. The percentage available is 3 to 4%, and the function is, it increases the initial setting time of the cement. and this ingredient is available in the form of gypsum. The next component is iron oxide, that is Fe2O3. The percentage available is 3 to 4%, and the function is to give color, strength and hardness to the cement. Next is magnesia, that is MgO. The percentage available is 1 to 3%. It gives color and hardness to the cement, and excess will make the cement unsound. So next ingredient is sulfur. The percentage available is 1 to 3%. So now the function. So sulfur, if available in a small amount, is useful for making the cement sound, and excess will cause unsoundness. And the last ingredient is alkali, which is available in very small quantity, that is 0.2 to 1%. And if this alkali is in excess, it will cause a number of trouble in alkali aggregate reaction, that is, while making the concrete, there will be reaction between the fine and coarse aggregate with this alkali. So that will decrease the strength of the concrete. So next is the ordinary Portland cement. We will see in more detail the properties of ordinary Portland cement. This was first introduced by Joseph Espedin in 1824. So it possesses very good adhesive and cohesive property, capable of bonding into a compact mass. So this ordinary Portland cement is obtained by mixing and burning the calcareous material and the argillaceous material. So we have already discussed the chemical composition. So next is the manufacturing of the Portland cement from the raw material. The first step is mixing of all the raw material, and the second step is burning, and the third step is grinding. So these are the three main operations involved in the manufacturing of Portland cement. So now the mixing of raw material, there are mainly two methods. The first is a dry process, and second one is the wet process. So in dry process, the calcareous material such as limestone and the argillaceous material such as clay are separately powdered in ball mill or jaw crushers, and they are stored in silos or hoppers, and they are mixed in correct proportion, and the raw material is stored in a storage tank. And in wet process, the calcareous material are crushed and stored in silos or the storage tank, and the argillaceous material is washed and stored in basin. And this crushed limestone from the silos and the wet clay from the basin are conveyed through a ball mill or a tube mill, and they are powdered or mixed to form a slurry. So the second process is burning. So the next process is burning. So this burning is carried out in a long rotary kiln, and this kiln consists of a steel tube of diameter 250 cm to 300 cm, and its length is 60 meter to 120 meter, and it is laid at a slight inclination of 1 in 30 towards the down end. and the spindle rotates about its longitudinal axis at a rate of 1 revolution per minute. During the burning process, cement clinkers are formed. So you can see the cement clinker. This is formed during the burning process. And the last process is grinding. That means the clinkers are powdered in a ball mill or a tube mill. So during this powdering process, 2 to 4% of gypsum is added, which is mainly used to control the initial setting time of the cement. And the finely grounded cement is stored in silos and it is weighed and packed in a bag. So next is the box compound. So after the burning process, the chemical composition of cement is like this. So first one is tricalcium silicate, which is known as halite, and its chemical formula is 3CaOSiO2, and in short we can write it as C3S. So its percentage by weight is 55 to 60%. Next is the dicalcium silicate, which is known as halite. Dicalcium silicate is halite and the chemical formula is 2CaOSiO2, and we can write it as C2S. The percentage by weight available is 50 to 20%. Next is the tricalcium aluminate, that is 3CaOAl2O3, and we can write it as C3A. The percentage by weight available is 5 to 10%. And the next one is tetracalcium aluminoferrite, that is 4CaOAl2O3 Sc2O3, and it is written as C4AF, and the percentage by weight available is 5 to 8%. And the last one is gypsum, that is CaSO4 which is written as CsH2, and the percentage available is 2 to 6%. So this compound is known as box compound. So now we will see the properties of the box compound. So C3S is responsible for the early strength, and the first 7 days strength of the cement is mainly due to C3S, and it produces more heat of hydration, and it is mainly used for concreting in cold countries. Second one is C2S. So after 7 days, the strength is mainly attained by this compound, and it hydrates and hardens slowly and provide much ultimate strength. So this compound is responsible for the later strength of the concrete, and it also produces less heat of hydration. So next compound is C3A, which is known as halite. So reaction of C3A with water is very fast. So this compound leads to the immediate stiffening of the paste, which is known as the flash set. So in order to prevent that, we are adding the gypsum during the grinding process. So hydration of C3A do not contribute to any strength. And the last compound available is C4AF, which is known as the halite, which hydrates rapidly. So hydration is rapidly attained due to the presence of C4AF. It also do not contribute to the strength of the concrete. So in the next class we will discuss about the main properties of the cement. So till then, thank you.